Hi, I'm sorry my face is so small. I have to put a photo and then clip my face in because I can't record from my phone and also show I can't record my phone and my computer camera's broken, so I couldn't do it on my computer and then record my face. Sorry. So I had to find a way around it. But this is my board, and I'm going to be presenting my Heated Up Science Fair project. And my project is optimizing heat shock temperatures for efficient bacterial transformation of P. amylase, which in short terms is just changing a variable, in which this experiment, the variable was the temperature for the water bath, for the heat shock step of a bacterial transformation. To find out how to increase the efficiency of a bacterial transformation with our enzyme of P. amylase. So the standard protocol temperature for the water bath is 42 degrees Celsius, so that was the control of the experiment. My hypothesis was that as the temperature decreased past the control, the efficiency would increase, but as the temperature increases, the efficiency will decrease. I ran the experiment at two other temperatures with an 8 degrees difference, so 42 degrees, 34 degrees, and 50 degrees. And I did this to get a general understanding of what would happen if we were able to run this experiment at more precise temperatures to see how it would affect the efficiency. So to run this experiment, there were many steps that were taken over a 3-day period with 2 additional days for incubation. The project was begun by preparing 9 LB and ampicillin plates and a tube of E. coli and RT broth. The competent cells had to be introduced on ice for 10 minutes before being able to mix 250 micromilliliters of the prep broth, and 250 micromilliliters of the transformation solution. Once those were able to be mixed together, 5 micromilliliters of the P. amylase was added to each of the 9 tubes. Those 9 tubes were then placed on ice for 10 minutes. 3 tubes were set at 42 degrees, 3 were labeled for 34, and 3 were labeled for 50. All of the 3 tubes were all put back on, they were put on ice for 10 minutes, and then they were introduced to the water bath for 50 seconds. After the 50 seconds, all of the tubes were then put back on ice. After the ice, 250 micromilliliters of SOC media without any antibiotic was added to the tubes. And then after a 45-minute incubation, 100 micromilliliters of each solution in the tube was placed on a plate. So there were 3 plates for each tube at 42 degrees, 3 plates for each at 34, and then 3 that were labeled for 50. The plates were incubated, which was supposed to be overnight, but it was left over the weekend incubating, which after immense research found out that would not have a big effect on the numbers of the colonies that would show up on the plate after. So after we counted the colonies, we were able to calculate the colonies per nanogram of DNA to get the efficiency rate. The results on the plates of the control temperature results was there was 5 colonies on one plate, 9 on one, and 89 on the last one, which for an average set for the data, the number of colonies was 34. And then for the set of data for 34 degrees, one plate had 29, one had 106, and one had 312, which reached an average of 149 colonies. And for the 50 degree plates, there was 1 plate that had 0, 1 plate that had 53, and 1 plate that had 133, which had an average of 62 colonies. This showed that obviously 42 had the highest number of colonies, followed by 50, and then 42 had the lowest, which was odd to me because 42 is the standard protocol temperature in almost every procedure I've read on this. So we use the average number to calculate the efficiency with the equation the number of colonies on the plate divided by nanograms of DNA plated times 1,000 micromilliliters, which showed that the 42-degree water bath efficiency rate, sorry. With that equation, 42 degrees had an efficiency rate of 42. The 34 degrees had an efficiency rate of 188, and 50 degrees had they had the rate of 78 colonies per nanogram. So 34 degrees having the efficiency rate of 188 colonies per nanogram was the highest, 78 colonies per nanogram, which represented the 50-degree water bath data, and 42 degrees had 42 colonies per nanogram. So the conclusions were that changing the heat shock stage of a bacterial transformation was the factor that could and would have the greatest effect on the efficiency by altering the temperature by only 8 degrees both ways. The efficiency rate was significantly improved by decreasing the temperature by 8. But even though 50 increasing the temperature also had a higher effect on the efficiency than the standard protocol temperature, it was still very significantly higher. It was almost double for I'm blanking. It was higher for the temperature to be decreased than it was to be increased. With this information, the experiment should and can be run at each degrees both higher and lower of 42 to find the maximum efficiency to have the most colonies on the plate if a scientist were to run an experiment in order to find anything they needed, they would benefit by having the most colonies on a plate. So with that, somebody could run the experiment at a 1 degree increment higher and lower to see when they reach the maximum efficiency with enough time and equipment, and one day could change the standard protocol temperature to increase the efficiency for any bacterial transformation, because with my experiment proved that the standard protocol temperature indeed was the least efficient. So that was my experiment. I'm sorry, this was very blotchy and very broken up. I was a little nervous, but that's it. Thank you.